Okay, let's do this last problem here. We got this. We can do it. I'm believing in us. So what is it? Well, we got a whole bunch of loads pushing on this. As a note, when it says 20 kips on both sides, it does mean 20 kips twice, or 15 kips twice, or 4 kips twice. It is on both sides. It says that axial loads are applied with rigid bearing plates. So these guys are rigid. They don't deform at all. They're magic. To the cylindrical rods shown, and it gives us the diameter of those rods. What we want to find? Well, we want to find the axial normal stress in each of these rods right here, here, and here. Okay, not too bad. We know what the normal stress equation is. It's just stress is equal to force over area. How could it be so hard? It's not, honestly. It's actually really, really simple. So what we're going to do, we're going to choose cutting planes. We're going to solve for our forces, and we're going to go from there. Okay. So for our first section, we cut through it. We have to find our internal force. If you look at this, we have 16 kips going down, which means I have to have 16 kips going up. Okay? So force 1 is equal to negative 16 kips. As a note, if you see negative when you're drawing it this way, that means compression. Always, always, always draw your arrows pointing away. If you do and you get a negative sign, it's compression. If you get a positive sign, it's tension. That's the case the entire semester. Okay. We got our first force. We want to get all of our forces, then we'll get all of our areas, then we'll get all of our stresses. We go to our second one. We cut through here. So we've got 16 going down. We have 30 going up, which means I'm going to have 14 positive going up. So 14 positive pulling down to keep it in equilibrium. And so that means it's in tension. So first one's in compression, second one's in tension. And let's go to the last one now. So I have 14 coming down because we already know what that is. And I have another 40 going down. Make sure I did this right here. Yep. Let me see. Did I do this right? Nope, I didn't. Sorry. That's 14 going up. There we go. And I have 40 going down. And so I need to have another 26 kips resisting that. So this is always just my sum of the forces equation, just if you're not clear. I'm just writing my sum of forces in the y direction is equal to 0, and I just go through. So that was 8 going down, so negative 8, minus 8 from these two guys, plus 30 from these two guys, minus 40 from these two guys, and finally minus F3. And I solve for F3, and I get that's equal to negative 26. So that's how I'm doing it, just so you know. These problems are not terribly bad. You will run into these. They're just time consuming. Okay, you're going to see these a lot. They're time consuming. There's lots of steps, but they're not bad to deal with. Okay. And I feel silly because I gave you all the forces, and I forgot to put the areas in here. So let's go ahead and do that. Let's see what my area is. Areas are 2, 1.5, and 3. Okay, we got those. Let's go down the line. Oh, too big. Okay, so this one's got 2, 1.5, and 3. So our areas then would be equal to, let me get my calculator out here because I don't have it in the PowerPoint itself. So area 1 is going to be equal to pi times 2 squared. Area 2, and basically that was a diameter, so that would be over 4. It's going to be equal to pi times 1.5 squared over 4. And area 3 is equal to pi times 3 squared over 4. And so this one will be just 3.14 because it's just 4 over 4. The second one will be equal to 1.766. And the third one is equal to 7.065. Okay. I have my areas, and now I need to figure out what in the world are my stresses. So stress 1 is going to be equal to 16 over 3.14. Stress 2 is going to be equal to 14 over 1.766. And then stress 3 is going to be equal to 26 over 7.065. I'm ignoring signs right now because we didn't really ask us whether it's compression or tension. So I'm going to ignore that for the moment. And I get that this was going to be a stress of 5 KSI, kilopounds per square inch. Second one is going to be equal to roughly 8 KSI. As a note, I am rounding. And the third one is going to be equal to 3.7 KSI. Okay, there we go. I forgot to put that in there, but we did it together. So that's the problem. That's how you do it, one step at a time. Get your forces, get your areas, and we're going to be using our statics equations the entire semester, so make sure you're practicing with those. Thank you all so much, and I will see you all later. Bye-bye.